Yeah, thanks. Hey. Yeah, welcome everybody. Do you hear me? Is it loud enough? Yeah, I don't want to scream. Well, I might be screaming. Yeah, my name is Frederik. I'm currently working for KF, which is one of the companies that actually implements the Centrifuge protocol and ecosystem. And I'm going to talk about how we, in the past month, kind of changed our protocol into taking into account the multi-chain word and became, cross-consensus application protocol, which is, a funny word, but yeah, it's hopefully what we're doing. And why did we actually go that route? Well, I think for us, in the past month, we came to the realization that we kind of have to accept the multi-chain word from a different perspective, and for us, this means that currently still a lot of liquidity and a lot of users live in the Ethereum world and the L2s of Ethereum, while the capability that our chain provides, and the protocol actually provides, all lives on Centrifuge. And we kind of, in order to actually make our product useful, we actually need to connect somehow or bring the users to a system, bring the liquidity to a system. And what I'm talking about is the process on what we did in order to actually go there or get there. And what this means for us, well, first of all, compared to only looking at our own chain, we now need to consider that we got more asynchronous logic happening, which is if we have some execution in Ethereum happens and then the bridge is in between and now it reaches our chain. This means that the sequence of execution might not be the same, and also the user might already trigger some interactions that that change how we would actually react depending on when we receive the messages. So this is one of the first things we needed to consider. The second thing for us was that we wanted to have a protocol that actually takes advantage of the possibility that the Sub0 chain provides, which is, we can control everything that's happening there via democracy, but it's custom made. We have high performance compared to all the L2s, the execution cost is really low compared to other systems. But at the same time, the protocol previously did not really make it easy for users from other domains to come to our chain, to make it easy to bring liquidity to our system. So this is the second thing we wanted to consider. And the third thing is that our application in general was built, thinking that everybody would just interact with our chain. But if we have different chains that are coming to us, we will have a manifold of accounts, we will have 20-byte accounts, we will have 32-byte accounts. We have a bridge in between that actually introduces a lot of delay from user experience, because there's just time passing in order to finalize, for example, Ethereum, and then it reaches our system. And we have a lot more complex tokens, because we basically now are working with wrapped representations of the native currencies. And this just makes everything a little bit more tedious from a user perspective, and the user experience should still be good while being on a blockchain, which is anyways a different topic. So what did we actually do in order to handle all of these problems, or tasks, let's name it tasks, is first of all we added EVM capabilities to our chain, and our main goal here was that a lot of our issuers need custodial key management. We wanted to have all the tooling. For example, Fireblocks is something that they just need in order to handle private keys, especially from a regulatory perspective. When you have funds from other users that you need to take care of, you need some dedicated tooling for that. And furthermore, having EVM capabilities allows users from, let's say, an Ethereum chain simply connect to our app. They can use a MetaMask wallet, they have the same private key. They don't need to go through the hurdles of actually, creating a Polkadot.js account, managing a new private key, everything around that. It's just easier for us. The third one is something that we're not yet sure if we want to enable that, but there might be locations in our code where it's beneficial to have certain computations being done on custom code. You know, an issuer who wants to calculate the price of something can just provide its own price calculation without us having to do a runtime upgrade, but we're not sure if we want to add that yet. And the fourth point was something we just experienced, I will come later to that, which is using the EVM actually for bridging. So how did we do that? EVM capabilities for substrate-based chains are pretty straightforward. There's this Frontier crate, which is really nice, so thanks for everybody developing that. It provides a really easy way to extend your RPC endpoint with something that's Ethereum JSON RPC compatible, so all the tools can just work with your chain as they're doing with any other chain anyways. And it furthermore provides also an easy way to build Ethereum blocks, so you can actually use an Ethereum scanner or something like that. For us, it was quite fun because it wasn't that bad, but just to take something into account, this is the implementation of the block import queue that Frontier currently provides, and as you can see, this ensure lock there basically assumes that every block that you want to import already has the consensus digest lock from the Frontier logic in it. But we added it, of course, mid-flight, so our chain already had a lot of blocks. So when we first tried to sync, we just recognized that we couldn't sync anymore. So this if clause basically just ensures that you look for an EVM consensus digest just after the first EVM block that you generated. Haven't yet created a PR for that. I think a lot of chains who will do it mid-flight will have this error. It's a client-based change, so no runtime upgrade needed for that. It's just something to take into account. And now, of course, we needed a bridge. Otherwise it's pretty useless, because you need to trust the transitions basically that you're doing. And we try to design our system in a way that makes it easy. It makes it easy for us to actually change the underlying bridge technology that we're using. And also, depending on where you want to go, you might want to use a different bridge, depending on security or any assumptions that you want to make. So we have our application layer, and this application layer will just send a message and say, I want to send to Ethereum, for example. Our gateway logic, in the end, will actually see, do I have a way or any means of going to that destination? If so, I'm choosing the router that's currently set, and the router is actually doing the low-level stuff, which is, for example, we have something that just generates the right XCM instructions to forward, for example, to another chain to actually reach it, to just use the right bridge. And for the income stream from the Centrifuge perspective, the application always assumes that every message that it's getting is already verified. So the gateway has some storage that sees, this contract on Ethereum is actually allowed to provide messages to Centrifuge chain. If this is the case, it forwards the message, otherwise it just is discarded. So, and with this setup, we currently have the possibility to have multiple inbound streams for one chain, for one other domain, for Ethereum, for example, and one routing mechanism. We might extend it to multiple routing mechanisms, but this is something for security and for the future. So which options did we have? Well, there's Snowbridge, of course, which is light client based. Would have been super nice to actually use that. Unfortunately, our timelines did not quite meet. But I think with the current setup, we can, at least for Ethereum, we can quite easily switch the bridge mechanism. But this was just not possible for us, given our timeline. We also considered Nomad, which uses optimistic verification. But given the hack in the last year, we assumed that it would be rather unlikely that users would trust going over that bridge. And we also considered Axler, which is a blockchain purely used for bridging. They actually have really, really nice tooling, a scanner where you can see all the messages. The gas handling is super, super trivial. Calling the contracts on the EVM chains is super easy. So yeah, we're really happy that we went with Axelar in the first run, at the first iteration currently. And yeah, how did we bridge actually? You see there's option A, so there are also some others coming. We actually firstly wanted to have a native integration which is using a new Axelar VM. And this would have been a pallet that could be deployed on BridgeUp or as a local pallet if you're a standalone chain, or if you're a pair chain that doesn't want to hop over BridgeUp, you know, whatever you like most. And how this would have worked is we at Centrifuge developed this pallet, Axelar CGP pallet, and this pallet basically implements the normal flow that Axelar is currently using on the EVM, which is some relayers who are, you know, allowed to sign a batch of transactions, will actually sign them, provide them to your chain, they get validated, and then you can execute them one after the other. And as I said, you know, you can either host it locally or on BridgeUp, and the local host would basically be, after everything is verified, the last step would be there's a trade consumer, and you can say, you know, I now want to forward to pallet Y on my local system. For BridgeUp, this would have been something like I generate XCM instructions containing a universal origin from XCMv3, and then the pair chain could decide, you know, I'm trusting BridgeUp, and hence I you know, agree with BridgeUp that this is actually an Ethereum message, and then you just generate your Ethereum message, and then you can execute locally. I think this is the same that what Snowbridge is currently using on BridgeUp. But the problem for us here was that the Axelar VM stalled for quite some time, the development at least. We recognized that the APIs on the VM side on the new approach were, you know, changing swiftly, and it was just a little bit hard to estimate if this is actually possible for us. So this is why we went with option B, which is we had the AVM anyways, and Axelar is able to deploy on substrate chains with EVM capabilities. Moonbeam has this, for example. So yeah, we just thought, okay, why not just deploy Axelar on our EVM? And this is actually what we did in our test networks. Right now it's already live, that we have the Axelar gateway contracts deployed there. And you know, Axelar just deploys them like they're usually doing. A message is coming, it's verified from the Axelar network, reaching the gateway, and afterwards it will actually forward to a contract that we deploy that implements the Axelar executable contract, and this contract then forwards to a precompile. And this precompile for us is basically the bridge between EVM and substrate for us. And the precompile is a pallet and a precompile at the same time. And it has some, you know, admin controlled storage, which is democracy in most cases, where you can basically say, you know, I want to trust this EVM contract to be a forwarder, and then everything is basically allowed, and we recover. You know, Axelar is using string-based identification of chains and addresses, and the precompile takes care of actually generating, you know, a Rust-type substrate-based address that we defined in order, you know, for the rest of the system to understand it, and then it generates a local origin. That's the only one that's allowed to call our gateway. You know, a locally generated origin. And then the gateway takes care of the rest of the process. You know, but yeah, as things never really go as you plan in the world we live in, especially, you know, with the, I would say, bleeding edge technology that we're using, our currently used solution, also due to timelines, but also as a fallback, is that we are actually, you know, option B works, but we know that we cannot deploy to mainnet on time. So option C for us currently is that Moonbeam already has an Axelar bridge deployed, which is working. So we are actually right now, other domains, let's say Ethereum, Base, or Arbitrum, they're calling the gateway contract on Moonbeam, which actually forwards to a contract that we deployed, which also implements iAxelar executable, calling the XCM transactor, And the XCM transactor then uses XCM to call into our centrifuge chain. And we have there's this origin converter on the XCM config, which actually checks, depending on the multi-location, which origin I'm going to generate. And, basically the first one there is something that checks the storage. Is this a Moonbeam? Is this a Moonbeam parachain? Is this contract a relayer? If so, we generate a local origin, and then source address and everything is recovered. Because on Moonbeam, we're prepending the original source chain and source address in order to recover it. Otherwise, it would look like it's coming from Moonbeam, which is not the case for us. So in the end, we have something like that, which is, you see the gateway origin domain. This would be native integration and also direct integration via bridge hub, depending on how we generate it. And then we have our XLR relay origin, which actually recovers the original source chain, source address, and then does all the validation. So yeah, this is how it's currently working in the test nets. To be honest, not really problematic. So for me, it was kind of nice to actually use XCM in that way. So yeah, I was quite happy about that. And then, yeah, the fourth thing that we did was, actually extending our protocol to cope with, the three obstacles or differences that I mentioned at the beginning. And for us, this, the idea we had was that we have a set of messages that that actually trigger, that tell the other domain or the other consensus system, hey, something happened, you need to adapt now. You need to do what you need to do in order to, take account for that. Those messages have some directionality. So we have incoming ones. Those will always flow into Centrifuge from other domains. I just named a few here. We currently have 27 messages around that. We have outgoing ones. This is Centrifuge telling another domain, hey, for example, we're having this pool concept where you can invest into, and this means, Centrifuge is always the source of truth for that. So it's telling them, hey, I have a pool, you can use it now too. This is basically the idea. And then also we have bidirectional ones, which is, for example, token transfers, tranche token transfers, where you can send to another domain and also, also send it back to Centrifuge, depending on what you need. Yeah, as we wanted to make it as easy as possible on the EVM chains, mostly for complexity and cost reasons. And this is why, we are not using scale codec for that reason. Well, scale codec is used for fixed byte arrays because it's just bytes. There's no endianness that you need to take into account. We use big endian encoding for all, unsigned 128s, for example, or unsigned 16, everything that's multiple bytes. For more complex types, we have a custom byte encoding that just makes it easy for Centrifuge to generate an enum, for example, or anything like that. And how would this actually work? Well, if our pallet liquidity pools is basically the pool that's interacting with other domains. And we would basically, anybody can trigger this add currency message because during registration of an asset, the location in the ORML asset registry actually contains all the information to which other domain this belongs to, which is democracy controlled, but then adding a currency to another domain is actually, permissionless. Of course, it will only work once, but you can trigger it multiple times if you want to. And, let's just say pallet liquidity pool says, well, I have USDC on Ethereum. I know that it exists, and you can invest with that. And then we're telling them, this contract address, this ERC20 contract address is USDC on our chain on this domain, and liquidity pools on the other domain can accept it as a payment currency. And then secondly, if there's a pool created on our system, the pool admin, this is not permissionless, the pool admin could say, well, I would like users from other domains to actually invest into this pool. So they can trigger an add pool message. And afterwards, they would also need to tell them, well, because you can invest basically with multiple currencies, then you need to say, okay, for pool A, I would also be fine if users would use USDC. So the admin can say, well, at pool currency for pool A, which is USDC. And now Alice, well, actually we have KYC on our chain, so nobody from other domains can invest if they are not allow listed on Centrifuge. So there is, and you can sync the states basically between the chains in a way that the user can use their normal keys on Ethereum, for example, but I just omit this now. Let's just say Alice is is allow listed. Then Alice would just use her USDC. We lock it on the pool. This is basically the pool on the other domain locks it, tells our chain, hey, we locked some tokens. We want to increase the invest order. So we take this wrap representation just as an accounting means and invest it into our system. Yeah. And the assumptions that we had here was basically that the other domain for us is always the liquidity source of truth, because this is where the real token lies. They're not bundled all together, but on a per pool basis. The pools themselves are 4.626 compatible, so they work with any other tokenized vaults. And we try to keep the complexity as low as possible. Yeah. And Centrifuge on the other side is actually our asset source of truth, where the professional users that generate loans, that bring real-world assets to our system, actually interact with in order to benefit from the low costs. All the valuation, how much the tokenized vault actually is worth on the other domain, also happens on Centrifuge. The prices can also be synced via some messages. And all the computational complexity, which is automation, everything that Sub0 is really great about, happens still on Centrifuge, so that we can actually benefit from that, hopefully. And lastly, mostly because of the wrapped tokens that we're having now, we needed some means of actually handling that without needing the users, for example, to sign in 5 minutes later, sign another transaction, basically automating everything around that. And for that reason, we developed this palette for investments, which is between this liquidity pools palette and the other palettes that we're having that work natively on our chain. And you can think about it in a way that every message that comes in basically for an investment has like a rather huge state machine, where every user basically, if you increase an order, this will not just result in you can invest directly, but palette for investments will check, hey, is this actually the currency that the pool wants? Because they only want a single token. You don't want issuers, for example, to handle 20 currencies. And then what we're doing is basically we're just changing the state machine depending on what's coming in, and doing some stablecoin swaps in between. And just to highlight, this got out of hand quite quickly, I would say, because in the top right, the green one is actually the start, and this is like the full state diagram that we're having, which is, depending on what valid message is actually coming to a system, every message will basically trigger a different action, meaning, we're swapping into another currency right now. If you decrease your order, but we already have swapped, let's say, Ethereum USDC for the USDC, Polkadot USDC that we actually want, we need to swap it back. So everything that's concerned with that basically happens without the user doing something, and bots can basically drive it forward permissionlessly. Okay, problems is always of course this is my opinion, but this is just something we stumbled upon during developing that, which is fees it's really hard to manage fees currently, at least from my perspective. I would say it's really hard to get an estimate. It's really complex with respect to tokens. For example, we are using the EVM transactor for Moonbeam, and it's great that they developed it and that we can use it, but we can only use Glimmer with our sovereign account, because the EVM instructions are just generated in a way which makes it impossible to use another one. And we can of course write our own. You can always do your own, but I think it would be great if the ecosystem generally would just maybe standardize or do something which makes it easier to handle that. Also us, but just something we discovered. Account derivation is also a pain. Most XCM logic has like this location to account ID naming, which is mostly a tuple, but I would say it's different for every chain, and there has been some standardization. We're currently also using the one that Moonbeam is using, and also parity system pair chains partially also use the same derivation for multi-locations to local account IDs. But I would say there's still no endpoint where you can say for every chain, for this multi-location, what is the actual account that I get? And you need that in order to fund them locally, to get, to buy execution, for example, on the XCM instructions or something like that. So yeah, also something that's not trivial to deal with. And usually I spend most of my time just looking at code of other chains to see what's actually happening. Then bridge complexity, I think it depends on capability of XCM are definitely greater, but the actual interface is really that simple, and currently it's also hard to reason about how you should construct instructions that everybody does it in the same way, I would say. And the last thing, which is just the nit, I would say, but currently it's impossible to transfer variable length byte arrays and use it in a transact call on substrate if you are not using scale codec on the other domain, meaning every bounded vector and every vector is prefixed with a compact unsigned 32, which is scale encoded, and the compact ones have custom encodings. So we basically need to rewrite or copy paste this custom encoding on the solidity side in order to insert raw bytes into a transaction. Otherwise, it will always fail to decode. Yeah, this is just some things that we recognize and that I think would be nice if the ecosystem in general, or we in general, everybody can maybe think about how we can ease the experience of doing that. Yeah, that's basically it.
Yep. Thank you, Frederik. That was really interesting. So, do we have any questions for Frederik, and maybe something about how cross-consensus applications are being developed? So, no? Actually, maybe I would have one, because it seems like you put quite a lot of effort to actually make Centrifuge work across both Ethereum and Polkadot ecosystem. So, what was your primary motivation to be actually running on both of the ecosystem? What was the primary motivation to actually bridge Centrifuge as well to the Ethereum, and to have it working like both on the Ethereum side and on the Centrifuge side as well?
Yeah, mostly for us this was, we need a chain like Substrate to do the complex computations. It's almost impossible to, well, it's definitely possible, but it would be a hard turn for us to do it on a Ethereum Solidity-based chain. So we know that we need that, but at the same time, we have USDC now on Polkadot, but liquidity still, I would say, is in Ethereum mostly. Well, it's not an easy time for everybody, but it was just a matter of fact, and we just recognize that we need to, actually, in order to, approach DAOs, to actually, which are living natively on other systems, it's just the way it is. We just need something for them to, trustlessly invest into a system. Yeah.
Yeah, that makes sense. Yeah, and also maybe you were mentioning like the options you were thinking about when using a bridge. So in the end, you end up choosing XLR. But did you consider maybe Wormhole as well? Because that's something a lot of parachains currently are using before the Snow Bridge is going to be alive, hopefully this year.
To be honest, I'm not sure why we didn't consider it. I think for us, XLR was the more convenient approach. But as I said, I hope that we can, switch to Snowbridge soon. So, and if Wormhole is also there, we have the idea of, depending on how much money you're actually transferring, that you need multiple confirmations over multiple routes, just for a security perspective. And then, of course, we would consider, just adding, for example, you need one Snowbridge confirmation and also one XLR confirmation if you want to send above 1 million or something like this, depending on what you actually want to trigger. But yeah.
Yep. And I think that's really interesting for like a bridging feature to have like multiple options actually. Maybe one less secure with paying less fees, obviously, but maybe the other one which is like really, really secure, but also kind of expensive as well, like based maybe on the light clients.
I personally would, the light client-based approach, I would say, is the most promising one. But yeah, because it's most trustless. But yeah, let's see.
Yeah. All right. Yeah. Thank you. So still no other questions? Yeah. Perfect.
Hey there, hey Frederik. I'm curious in, on the Ethereum side, do you charge a fee to users for sending data across to Moonbeam and the XLR connector?
Well, yeah, currently in the test networks not.
Okay.
Currently in the test networks it's basically just, we don't do an upfront payment, but Axler allows this easily to just charge a payment and then you charge for the transaction, but this only charges for the transaction on Moonbeam. The Centrifuge execution must be paid in Centrifuge in order to not drain our sovereign account, and this is something that probably our app in the long run, that you sign, that you sign a transfer to the account that actually buys the execution on XCM, then you trigger the message and then you already have funded the account and then you pay for it, basically from this way
Okay,
onward.
cool.
Yeah.
So
because otherwise you enforce the user to have CFG on Moonbeam, which is user experience-wise a nightmare. This would never happen.
Yeah. Okay, cool. That helps, thanks.
Right. Anyone else? We still got some time. All right. Seems like that's it. Yeah. Thanks a lot for your talk.
Thanks a lot.
Yeah.